Okay, in section 3.1, we are going to talk about obtuse angles. But before we get there, I want to review a little bit and then kind of set you up for some of our terminology and notation. Okay, so here's what we've been looking at so far. We've been looking at right triangles, right, with a base angle of 90 degrees here. We have an angle theta. If I had a triangle with sides 3 and 4, we could use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for the hypotenuse, right? So we can have 3 squared plus 4 squared is c squared. I know that 3 squared is 9, and 4 squared is 16, and 9 and 16 is 25. That is c squared, and so c is equal to 5. So the Pythagorean theorem tells us that our hypotenuse is 5. Now what we also learned in the last chapter was the SOHCAHTOA, or trig ratios, right? So notice here that I'm going to take sine of theta, okay? And sine of theta is opposite over hypotenuse. In this case, it's 3/5. Cosine of theta, that's adjacent over hypotenuse. In this case, it's 4/5. And then I have tangent of theta, which is opposite over adjacent. So that's 3/4. Okay. Well, buy into this for a second, and then hold on to the thought, because we're going to come back to this. I can just reflect my triangle, right? I can just flip it over. It looks exactly the same, right? And because all the angles are the same, the dimensions are the same, right? You buy that these are congruent angles. My angle right here is still theta, and that sine of theta is 3/5. Cosine of theta, that's still 4/5. And tangent of theta is 3/4, right? You still buy that. Exact same triangle. Not quite on a scale, but you get the idea. The proportion, or the ratios of sine, cosine, tangent of my angle theta are still the same. Okay. What we're going to do shortly is to put these triangles into the xy coordinate plane, the Cartesian coordinate system. Now before we do that, we need to get some terminology or conventions down. Okay. So let's look at angles in the xy plane. Okay. So whenever we talk about angles, we always start at the 3 o'clock position. Alright, so whether we're in degrees or radians, 0 degrees and 0 radians. I'm not sure why this is happening. My pen keeps doing that. This is 0 degrees, it's also 0 radians. Okay, we always start in the 3 o'clock position, and positive angles are measured this way. Okay, so this is the positive direction, that's counterclockwise. Okay, so if I wanted to measure out a 30-degree angle, right, I go up this way, right, and this is about 30 degrees, right? So this angle right here, this green angle, is 30 degrees. Okay, we know that there's 360 degrees around the circle, around one revolution of the Cartesian coordinate system. This is where 90 degrees is. This is 180, right? Because an angle like this, measured from 0, forms a straight line. That's your straight angle. Down here is 270. And then back around to 360, okay? And you can go around again, right? If I started here at 0 and made a full revolution and went back up to this green line, I have traveled 360 degrees plus another 330. And so a coterminal angle, let me write that down. I'm going to do undo for that line. I don't know why that's happening. A coterminal angle, coterminal meaning that it ends in the same place. Coterminal angle of 30 degrees is 360, I'm not sure what's going on, plus 30 degrees, which is 390, okay? And I can go around again, right? Another 360 would be 720 plus 30. Another coterminal angle of 30 degrees is 750 degrees, okay? So 30 degrees, 390 degrees, and 350 degrees are all what are called coterminal angles. Okay? Now, let's say I want to go in the negative direction, right? What is a negative 30-degree angle. Well, that means I have to start at 0 and go clockwise. Okay? Say this is 30 degrees. This is negative 30 degrees. Okay? Negative 30 degrees is the same thing as going around from 0 in the positive direction and landing 30 degrees shy of 360. So that would be 360 plus a negative 30, which makes it coterminal to 330. Okay? Similarly, okay, if I wanted a negative coterminal angle, I would have gone negative 30 degrees plus another negative 360, right? And that would be negative 390. Just to show you, right, I make one full revolution and then I go around again. Sorry, that's the wrong direction. I would start here. I would make one full revolution, that's negative 360, and back down to here would make that negative 390. Okay, so it's very easy to have positive coterminal and negative coterminal angles. Just to make it clear, I can come up with a negative coterminal angle for 30 degrees, right? Basically, I just go in the negative direction and I'm 30 degrees shy of one full revolution, right? So that's negative 360 plus 30 degrees because I'm shy that. So basically it's negative 330. I know that was kind of a weird way to compute it, but basically I've gone a negative 360. Negative 360 would take me all the way back to 0, right? But I'm a little bit shy, so I add back the 30 degrees, and that's why it's negative 330. Okay, so be able to find both positive and negative coterminal angles in the xy plane. In the next video, what I'm going to do is I'm going to show you what happens when we put our triangles into the xy coordinate plane and we start talking about supplements.